Today I am going to explain you about the program on serial port communication, which is a last experiment in the part A of your lab experiment. The statement goes like this: conduct an experiment to configure 8051 microcontroller to transmit characters all is well to PC using serial port and display on serial window. So this statement, I have created a block diagram to understand this. Say there are two data terminal equipments. The one data terminal equipment is microcontroller 8051. So from here, I am supposed to send the characters all is well to the another data terminal equipment, say PC, and it should be displayed in a serial window. So first, in order to configure this, connect in a hardware mode, so the two terminals which is available in the microcontroller 8051, the TXT and RXT need to be connected in this way, in this fashion. How it is? So the TXT must be connected to the RXT of the another DTE, and the TXT of the PC need to be connected to the RXT of 8051, and the common ground should be provided. We can configure externally. Now, how to write a code to send this information from one DTE to the another DTE? How it can be displayed? So, in order to write the code, first we have to understand the procedure given over here. 8 steps need to be followed. What are those steps? Starting with first one, let's try to understand the first step. TMOD register is loaded with value 20H, indicating the use of timer 1 in mode 2 8-bit auto reload mode to set the baud rate. Now the first statement you can observe after the originate the location. First statement what we are using is TMOD and I am passing the value 20H. So by moving like this, what are we doing? We are setting timer 1 in mode 2, which is 8-bit auto reload mode. And why we are supposed to use timer in serial communication? Because the DTEs works with the proper baud rate. Especially when we go for serial communication, we have to understand what is baud rate. Baud rate is nothing but a bits per second. Say your microcontroller is very fast, and but your the another DTE or the peripheral device which is not fast comparatively to your microcontroller. Then, in order to create a speed compatibility, we have to match the baud rate. So, in order to create enough delay from microcontroller to the another DTE, so this is must. Say your PC is working with 9600 baud rate. So, in order to set your microcontroller in that pace, we have to use a particular timer to set the proper delay. So in this way, first I am using timer 1 mode 2 8-bit auto reload mode here. Let's look at the second point. In TH1 is loaded with one of the value to set the baud rate for serial data transfer. Now, since I am doing communication with the PC, I know the baud rate speed of the PC is 9600 baud rate. So that's why I have to move a decimal equivalent value -3 to the TH1. Timer 1, or you can directly move hexa value FD to this. So if the DT are different here, say your mobile or some other serial communication devices, by looking at the specification given by the manufacturer, say 4800, 2400, likewise the TH and TH1 will be loaded with the different values, or you can use the hexa values also directly. So by moving this, I am setting the 9600 baud rate speed of the for the communication, serial communication. Now the third step, the SCON register is loaded with value 50H, indicating serial mode 1, where an 8-bit data is framed with start and stop bits. Now, in order to send any data from one DTE to another DTE, I have to set a proper mode, serial mode communication. So here in this diagram, it's a bit specification is given here. SCON is a 8-bit register, special function register. By moving 50H, That means the equivalent binary value is 0, 1, 0, 1, which is 5, 0, 0, 0, which is 0. So it's 50. By moving or setting some particular pattern, what happens? Let's look at these two first, SM0 and SM1. By moving 0, 1 here, so we are setting, especially 0, 1, we are setting serial mode 1. It's a mode 1 serial communication. We are sending 8 bit at a time. Along with that, one stop bit, one start bit. So how does it look like? It looks like this. The start bit will be moves first, goes out first, and the following bits are your 8 bits. One character at a time, which is 8 bit data. The last bit that goes out last will be stop bit. So in this way, it will be formatted. So that means by passing 0, 1 to this, it is going to be set in this fashion. And this is not required. SM2, that's why I have moved 0 here. REN is receiver enabled. This initially we have to make it 1. Then TB8, RB8 is not used. So you can see here, not widely used. And TI, initially it will be 0. Since we are transmitting the character from microcontroller to the other devices, GTEs. So it's a transmission operation. So initially TI will be made 0. If it is RI, we will monitor. RI stands for it's a receive interrupt flag. TI stands for transmit interrupt flag. Since we are transmitting the data, we have to monitor this bit. So this bit will clearly give you the information regarding whether the data is being sent or not. So in this way, so by moving 50H data, what are we doing? Indicating serial mode 1, where an 8-bit data is framed with start and stop bit. Next let us look at the next parameter. TR1 is set to 1 to start the timer. So in order to create this amount of a delay, 9600 baud rate, this has to be initiated. Set B TR1 with this instruction. Next, clear is cleared by clear TI instruction. So this we have already done by passing 0 to this. So by moving that data, we had already done. It is by default it is 0. So need not to take care of this particular instruction. Next, 6.1. The character byte to be transferred serially is written into the FBUF register. So how it can be done? See, prior to that, where are we storing the information? What is our information? As we can see here, from here, all is well is our string. So that is stored in the external ROM, and the location is starting from 300. So you should be initiating this first, and at the last you need to pass a null character. So whenever your microcontroller finds a null character with this instruction, it will jump to the last. So till it finds this, you keep on sending this data one by one serially. So the data which is stored externally in this location is given over here. So that is initiated with the help of DPTR. Move DPTR. This is the address, starting address of the external ROM where I stored the all is well information. Next, clearing the accumulator. Since I am going to use indexed addressing mode to access each character, so I am going to clear A. So this is the first step we have to keep it in our mind. Since we are going to for indexed addressing mode, accumulator must be cleared. So move C. C indicates it's a external ROM. So external ROM is accessed now. So how it is accessed? It is 0 now. Accumulator is 0 by using this instruction. DPTR is 300. At 300, the this character, A character will be accessed and will be moved to the accumulator. Now accumulator is having some equivalent ASCII code or equivalent 8-bit data. So when it comes here, jump 0 last. This will be true only when the accumulator consisting of the null character 0. Now it is false or it is failed. So because of that, it comes to this instruction. What is this? Move SBUF. SBUF is a serial buffer, which is a 8-bit register, and the accumulator content must be moved to the serial buffer before transmitting the data to the another DT. That's the procedure. So that's why you can observe in this diagram. So inside the microcontroller 8051, there is the SBUF register. So prior to the sending to the any other DT, the data must be stored in the serial bus first. Later, it will be appended with the start and stop bit. Then it will be serially transmitting bit by bit in this fashion. Now I am going to transmit to the another DT from this wire, this channel, a single line channel. How it is taken care? So with this instruction, JNB TI gauge. So what it does, you can observe here, they have clearly told here the TI flag bit is monitored with the use of instruction JNB TI XX. So there is a label to see if the character has been transferred completely. Let's try to understand what it does. Jump no bit TI. When the TI becomes 1, initially we had sent 0 here, so by default it will be 0. So that means this will set only when set by the hardware at the beginning of the stop bit mode. Stop bit mode will be seen at the last bit after the data. So that means we have sent one character completely. When it finds a stop bit at the last bit as the last bit, immediately the hardware makes TI flag 1. When it becomes 1, this indicates we have transferred 1 bit character from one DT to the another DT successfully. So soon immediately we have to make clear TI. So because of why I am using this instruction, just to ensure that the next character is yet to be sent. So that's why I am clearing the TI. So again, your computer will assess whether the next character goes in a proper order. So in this way, we are going to monitor JNB. So this instruction which is very helpful in transmitting the data character, each character by character. So in this way, the A will be sent first. Immediately, as when it recognizes the stop bit, it it comes over here, clear the TI, increment DPTR. That means I am pointing to the L now. So again, it goes back here, clearing A. Because of we are going to make use of index reversing mode. Again accessing this data, moving to the SBUF, again monitoring it till it comes stop bit. So in this way, when we pass all the information, all is well successfully, the last character, which is a null character, is moved to the accumulator. Now this instruction satisfies or it becomes true, then it will come to the last. That means we have successfully transferred all is well from your microcontroller to the PC. Thank you.